In the last video, we looked at the quadratic formula, which is a great way to solve quadratics because it always works. No matter how ugly our answers are, if they're irrational or even non-real, we'll still get the solution. So this one's nice because it always works, but as you can see, it can be pretty tedious to do the math. Instead, what I want to do is show you one last method called completing the square. The name comes from the box method that we've talked about before. We want to complete this box using what we do know about the equation. So we've seen this before where we have our factors representing a sort of geometric problem where the area inside is our standard form. Okay, so let's look at the problem I have here. So this quadratic can't be factored. There's no factors of 1. They're going to add up to 6, 1 times 1 being my only option. That's not going to work. So what I'm going to do is going to be a little different than what we've seen before. I'm going to move 1 out of the way. I'm going to add 1 to both sides of the equation just to get some space to work with. Okay, now what I'm going to do is I'm going to manipulate this equation. I'm going to put some number in here, and it's going to be the perfect number so that this factors, not just factors, but factors into a perfect square. And you'll see why I want it to be a perfect square later on. Okay, so let's see what we know so far. I know that I have x squared, which I've already got in my box here, and I've also got 6x. So I know from my previous experience with the box that the x parts go into these two boxes here. And like I said, I want this to be square, meaning the sides are the same. So I need this to be cut in half, 3x and 3x. Okay, so I already have this much in my equation. I have the x squared, I have the 6x's. I'm just missing that last piece. I need to complete the square. All right, there's the term. So you can see in my box that the number I'm missing, the number I really want, is a 9, because 3 times 3 is 9. So that's the number I'm going to throw into my equation right now. I'm just going to throw it in there, plus 9. I'm going to add whatever number I need to make this factor perfectly. I can do that. I am allowed to just add 9, as long as we keep things equal. Add 9 on the other side, and we're good. Okay, so now I got 10 over here, not just 1. And now I'm going to factor this. So as you can already see in our box, this factors as x plus 3 times x plus 3, right? We just did that. So this one's kind of unique. The factors are the same, so we can actually write this a little bit better. This is x plus 3 times itself, or x plus 3 squared. This is why we want it to factor as a perfect square, because if I have two different factors and it's not equal to 0, that's tough to solve. But if I just have the same thing twice, the same thing squared, I can undo that. We know how to get rid of a square. We take a square root. So I'm going to take the square root of both sides, leaving me with the square root of 10, could be positive, could be negative, equals x plus 3. So x is -3 plus or minus the square root of 10. And those are my two solutions, right? -3 plus root 10 and -3 minus root 10. So completing the square can be a really nice method. It's totally algebraic, so there's no formula to memorize. It just comes from pure algebra and logic. Now this can get more complicated. I chose a pretty easy one to teach this, but you can imagine some complications. First of all, what if this number doesn't divide evenly in half, right? If I had a new problem, I hope this doesn't factor, we're going to have some complications. First of all, I've got this 2 here, and then 3 is not going to cut in half. Really nice. So there's some things we'll have to do to deal with those problems, right? The algebra skills might get pretty intense. We'd have to divide out that 2 in order to make this work. And now we've got 3 halves, and now we have to create a box where we have to total 3 halves. So we get 3/4. 3/4 x are our 2 pieces here. And now we got 3/4 times 3/4. So now we end up with adding in 9/16, which we can do. We add that to the other side, but notice this is not just 9/16 being added to the equation. It's 9/16 times 2 being added to the equation. So we'd have to do that on the other side as well. We can still do it, we can still fight through the math and solve it algebraically, but completing the square can get pretty complicated. So there will be times where quadratic formula might be your best route.